So, I was telling about very simple DC machines and a simple generator and motor consisting of a single conductor and placed under a magnetic field. If you excite it with an external voltage, it will act as motor, and if you give a movement, it may act as generator. Only thing about the motor I have completed. For the generator I will not tell much, except this information I must tell. You recall that in case of generator mode also, in generator mode, here also I assumed one thing, there is no friction like that, and only thing it is in fact no generator at all. Okay, somehow you have dumped some kinetic energy to the conductor. Initially it was running with velocity V naught, and the moment you try to draw power out of this generator, the power will be delivered to the load, but not for so long. Voltage will collapse gradually to 0, current will collapse. So long kinetic energy will be present in the conductor, that will be there. But what I am telling is that this I will tell in a nutshell now. In case of see generator, just to have for completeness sake on discussion on this topic, I will say that okay, suppose you have a generator on this railway track as we have drawn earlier, and very quickly I can write down the results. This is my AB conductor generator mode, generator, and it is running initially with velocity, and suppose I say like this, it is running with velocity v at constant speed, and then I say that the generator is supplying a resistance like this, and your B is in this direction. So, polarity of the voltage induced will be BLV, is not. Now, suppose I say that this generator is found to deliver a constant current of value I. And the conductor was found to run with a constant velocity v. You get me? That is, the conductor is of length L, moving. It was found at one time that moving from left to right with velocity v, and we know voltage will be BLV, and it is delivering a constant current which has to be equal to BLV by R. It was found, it is sustained. Now, then I will such a situation is present that it is moving with a constant velocity, and this one, is it possible? I will say yes, it is possible, because this conductor is carrying a current I. Therefore, this conductor experiences an opposite electromagnetic force Fe, whose value is BIL. It has to be, because if it is delivering a current I, then I will demand that it is running at a constant velocity. That means, some external agency must have applied a force to the right, mechanical force, matching this electromagnetic force. That is why it is running at constant velocity v, and current is BIL. Everything is in place. In other words, what I am telling is for a generator to continuously supply power, in this case it will not happen, the velocity will come to 0. So long there is an external fellow providing you this mechanical force which is equal to this electromagnetic force developed by the machine, which is from right to left. That is why that engine comes in. To run a generator, you require some mechanical assistance. Whatever power is delivered to the load will come from the mechanical system or prime mover. In case of rotating machine, it is called a prime mover. So, what is that prime mover? Maybe it is a diesel engine sort of thing which will give you this mechanical force. Got the point? Therefore, this is the called the prime mover, prime mover which drives the generator. So, to make a generator run, you must have some mechanical, some external agency which will provide this much needed mechanical force to match the electromagnetic force and make the generator run at constant speed. If any upset between these two happens, then also I know, because this is the net force acting is F mechanical. So, F mechanical must act along the direction of the velocity. If F mechanical is greater than F electromagnetic, it will accelerate. If F mechanical is less than F electromagnetic, it will decelerate. If these two are same, it will run at a constant velocity. Anyway, but this is in short the basic idea of a very simple DC generator, which of course, one will not manufacture because it is so non-ideal in the sense that very impractical, long infinite long rails what for. But this problem we have tackled to bring out several interesting points that in a generator and motor take place. Okay? It gives you an idea, okay, in a moving system, two forces will act on the moving conductor. One is the electromagnetic force, another is the mechanical force. In case of motoring mode, electromagnetic force will decide the direction of motion, and in case of motoring mode, it is the prime mover in which direction it is driving the generator, this one that will decide the direction of motion and so on. And we will come to these points several times when we start a real practical generator. So, go through this exercise, and as I told you, you can once again start, if you say mechanical force I have set, then how the final operating point will be reached and so on. We will discuss about it. Now, I will talk about another interesting generator of this kind. Now, in this type of generator, as you can see, this conductor is, it moves from left to right, and lines of forces are into the papers. Conductors never see a reversal of field, that is, it is always we will see north to south, lines of forces, it will cut and give you force. Okay. Let us see another generator, generator to make things clear. DC can be generated because that was so impractical. Now, I will tell you about a very practical simple DC generator, which is rotating type. Let us see how it will look like, very interesting. Suppose you have an aluminum disc. We will be discussing another simple type of DC machine, which is more practical. I mean, there is no doubt about it. And the structure or the constructional feature of this machine is, you take a aluminum disc here like this, aluminum disc, and a circular aluminum disc, and it has got a spindle about which it can be rotated vertical axis, okay, along this line, that is there. Now, on the top you keep a north pole, okay. Suppose this is a north pole above it, okay. This blue colored thing is a north pole, and below you keep a south pole, all along the covering the area of this aluminum disc. So, this is south pole. So, there will be lines of forces crossing this aluminum disc like this way. This will be the direction of B. The black one is the aluminum plate, aluminum plates. Okay. And this aluminum disc can be rotated about a vertical axis. Now, in a simpler diagram, I will put it like this, that you have this disc, okay, of certain radius, and this aluminum plate I now draw on the plane of this page. So, your axis of rotation will be here. This is the axis of rotation, and above this aluminum plate there is the north pole, below this there is a south pole. Lines of forces will be into the paper all over this. This I am not making it clumsier by putting so many cross here. And if this is rotated, suppose in this direction with some RPM, say n RPS, so many rotations per second, I am rotating it. Then final result I am telling, then if you connect a voltmeter between this center point and this rim of this aluminum disc, that is the periphery, if you connect a voltmeter, you will find there is voltage generated, okay, and that will be DC voltage. So, on the top there is a north pole here, and below this aluminum plate there is a south pole. So, magnetic field will be B and things. Now, why it happens? How do I get the voltage? So, for that what I am telling, you consider any line, radial line here. It consists of infinite radial lines, like this, one of them you choose. And then what I am telling you, and suppose the radius of this aluminum disc is R. Okay. So, it will be this one, and what you do now at a distance, this, let this point be O, this spindle point at a distance x here, you consider a small element, vanishingly small element dx here. This we concentrate on this element, and this I am drawing it in a here the dx element in a larger scale. Dx is small, mind you. Now, this, since it is moving like this, therefore, it will be, its tangential velocity will be along this line, it will be moving. Suppose that tangential velocity is V x, and this length is dx, and there is a magnetic field B into the paper, that this elemental length is C. Therefore, why not there will be induced voltage, because there is a magnetic field, there is a small element dx having a velocity meter per second Vx. Vx can be related to this n and radius. We will do that, but this is the thing. And how much will be the voltage? Voltage will be B length, that is dx, into Vx. And what will be the polarity of the voltage? B, right hand rule you apply, B V, and this will be the polarity of the voltage. So, this side of this element will become plus and this side will become minus. So, we expect a voltage is induced, this one, with this side plus, this side minus. Now, the question is why I have considered an element dx? Because of the fact, if you consider this whole length, you do not know what is the velocity. Okay, B is perpendicular, length of the conductor is perpendicular to B, but you cannot assign a constant tangential velocity to this whole segment, is not, because tangential velocity is a function of radius. So, that is why I have considered a small element. Anyway, if you divide this in small things, elements, then all the EMFs will add up and finally give you a voltage between this point and that point, some substantial voltage. If all the small elementary lengths, they become seat of EMF, with this polarity only they will become, and if you add them up you will get a substantial voltage. So, magnitude of the voltage is this one. Now, the question is, okay, there you have considered a single line, there are I mean infinite number of lines like that, is not. If you draw close by this line, many lines are there, many lines. Okay. And they are touching each other. This line, you will find another line close by touching each other. Then each one of them, these segments has become plus minus, no doubt. Then will there not there be a problem? These conductors are in contact with the next conductors, no insulation between. No, there will be no problem, because if you consider a radius here, if you consider an radius, all the points in this circle considered, they will be at equipotential. Therefore, there is no current in this theta direction, or there is no voltage induced in this direction. Why? Because tangential velocity, suppose somebody says no, I will consider the element like this here, I will consider the elements like that at a given hour, this element. Okay, then tangential velocity and the length of the element are in the same direction, they must be mutually perpendicular, BLV business. So, anyway, so that will be equipotential. So, no matter you consider just one element. So, all these elements are in parallel, that is what I am telling. So, finally, a finite voltage will be available between this point and this point, and we would like to and that voltage will be DC only, because B is constant, velocity you are running it at a constant velocity n, therefore, n RPS and so on. So, and we found that the elemental voltage for a single element is, if I say this is dEx in this element, what is the voltage? VLV. Now, what is the known input? Known input is this one, B is known and n RPS is known. Okay. Now, rotation per second is same at this point, rotation is same, but the distance traversed meter per second velocity will change as you move from origin to this way. How they are related? V is equal to what? Omega r. See, for example, here what will be the velocity? Velocity will be tangential velocity at any point here is equal to pi d n, is not? In 1 second this point moves how much meters? 2 pi r, and in 1 second n RPS, it is rotating n times. So, therefore, so much of meter per second will be the velocity. Therefore, tangential velocity V x of this element should be 2 pi into the radius here x into n, because rotation per second are same for all these. So, this is V x. Mind you, this is rotation per second s. So, this is meter per second it will become. Therefore, the elemental voltage has become d E x has become equal to B V x L here and velocity B L V, that is fine, that is okay, and this is equal to, put this value of V x here, it will be B V x is this is d x and this will be twice pi n x d x, is not. So, this will be E x. Then what will be the total voltage between point O and say point A? Potential, and what is the polarity? This side plus minus. So, potential voltage generated voltage between points A and O will be then 2 pi n b, these are constant and you have to integrate it x dx from 0 to r, where r is the radius, no resistance, nothing like that. So, it is a simple integration, it will be equal to 2 pi n b r square by 2. This is the final thing. Is equal to the generated voltage. We will continue with this in the next lecture. Okay. So, you will get a DC between the center and the perimeter, and this A point, these are all equipotential point. So, either this point or that point, I will tell you about how to collect this voltage and use it for practical purposes. Thank you.